procedure has to be the lower portion. I have explained about it. The spindle portion alone we are going to see in detail, which is the available in the upper and lower plate. The upper plate is the continuation, which is called as the inner spindle. The lower plate, it is considered as the outer spindle, right? So the lower clamp and upper clamp screws, you have to remember these two screws, which are going to play a crucial role in our practical, right? The lower clamp, if you tighten the lower clamp totally such that the upper plate is free to move, but the lower plate won't move. The upper plate, if it is able to move, it is connected with the vernier scales A and B, such that it starts moving. The vernier starts moving such that we can measure the angle, horizontal angle, from 0 to what is the degree of the next point. And if you continue from 0 to next, that is possible when you tighten the lower clamp and loosen the upper clamp. If you tight both upper and lower clamp, the instrument can't be rotated. If you tight the upper clamp and loose the lower clamp, right, the lower plate alone will rotate such that it carry the graduation scale and the vernier scale both, so there won't be any change in the reading which we have fixed, but the position of the telescope will get changed, right? So this thing you have to remember. In the horizontal circle you are having A scale and B scale. So the difference between the A scale and the B scale, from the figure itself you can judge it is exactly 180 degree. If it is here 0, there it will be 180. If it is here 90 degree, there it will be 270 degree. If it is here is 30 degree, there it will be 210 degree, right? So that is the thing. So the main thing in while measuring the reading is, in A scale you have to consider degree, minutes, seconds. In the B scale you may consider only the minutes and seconds, since the main degree we are going to consider with respect to A scale, right? So suppose we are having 30 degree, 40 minutes, 20 seconds in A scale. There obviously must be, it is 210 degree, 40 minutes, 20 seconds, right? So the 210 we no need to consider. So we require the degree, already we have fixed it is 30. Whether the 40 minutes 20 seconds is same in the B scale, that we have to check with respect to the vernier in both the end. That has to be noted down in our level book, right? So upper plate, its the continuation is the inner spindle. Lower plate, it is the outer spindle. Both are governed by the clamp screws, right? This you have to remember. Next is the assemblies. There are three major assembly. One we have already explained, the leveling head, the bottom foot screws with the try-back arrangement. Next is the horizontal circle assembly, which I have hinted about, that A scale, B scale, vernier, that portion is here, and above that only the alidade assembly. Alidade assembly where the telescope is holded, the A frame, you are able to see, I think, the letter A shape. Both the end there will be A, where the telescope get holded here in the horizontal axis perpendicular to this A, and this is the bubble tube setup, and it can be adjusted with the screw, and this is the vernier for the vertical angle, where it gives the vernier reading, and there will be a horizontal, there will be a graduated circle in the vertical circle, right? So here this angle can be measured And you have to remember, this is the horizontal axis or the Tronian axis, this is the vertical axis of the instrument. So 3 assembly you have to remember, and this is the line of sight of the telescope, eyepiece, objective piece. And then while holding the instrument in such a way, if both the scale in the vertical circle, we have seen in the horizontal circle A scale and B scale, in the vertical circle we are having C and D scale. So both the C and D scale has to fix at 90-90 or 0-0 based on the manufacturer. Some manufacturer they may represent here by 0-0, some manufacturer they may give by 90-90, right? It has to get coincident, then our line of sight is exactly perpendicular to the vertical and the horizontal axis, and our in theodolite become equal to the dumpy level also in that position, right? So the theodolite can be used as also the dumpy level when we hold the position like this, right? So the vernier theodolite is also called as the transit theodolite. The transit theodolite is one in which the telescope can be rotated in the vertical plane. It is able to rotate in 360 degree, right? So this is the diagram you have to try to draw in our laboratory or in your theoretical mode. Everything, this parts and diagram you have to remember and try to practice this diagram, right? So there are majorly 24 parts about this theodolite. We will see one by one. You can freeze it and you can see those parts. The bottom portion already we have seen the leveling assembly, the leveling head. See, this is the leveling head, right? This is the point where the leveling has to be made. Is used to attach the instrument to the tripod. This is the portion where it get connected with the tripod and attach the plumb bob along the vertical axis, right? This is the part you have to remember, the 7th one, leveling head. This you have to remember. Next, already we have seen the circle plate. In that lower plate, 18th part, right? This is the lower plate, this is the upper plate, right? The lower plate, see an angular horizontal plate with the graduations provided all around from 0 to 360 degree. From the top you can see it is 0 to 360 degree in a clockwise direction. The graduations are in degree divided in 3 parts, so that each division equals to 20 minutes. So in the main scale of the lower plate you are able to measure degree and minutes. When combined with the vernier, you will get degree, minutes and seconds, right? So the horizontal angles are measured with this plate. The size of the theodolite is defined by the diameter of this horizontal. This is 20 centimeter theodolite, 25 centimeter, 35 centimeter, 30 centimeter. Based on the size of this horizontal circle only, they say or define the theodolite, right? Next comes to the upper plate, where the horizontal plate to the smaller diameter provided with 2 verniers. In the upper plate only you are get connected with the verniers on diametrically opposite parts of its circumference. These verniers are designated as A and B. They are used to read fractions of the horizontal circle plate graduation. The verniers are graduated in 20 minutes and each minute is divided into 3 parts, 3 to 5 parts based on the manufacturer. Like the least count will be 20 seconds or 10 seconds. If it is 3 parts, 20 seconds. If it is 5 parts, it is 10 seconds, right? So majorly our instrument has this 20 second least count. You remember 20 seconds least count. So the same diagram here we are repeated. And continuing, clamps and tangent screw. Already I explained about the lower clamp and the upper clamp screw. Next is the tangent screw. See, this is the point 19, this is the tangent screw. This should not be touched oftenly. When there is any error or some adjustment to be made, when there is a change in the permanent readings, then only you have to, otherwise it is very precise, we should not touch this. And 15, this is the clamp screw which hold on both the plate, upper plate and the lower plate. This is also comes under the permanent adjustment. This has to be handled carefully. Both the screws we have to handle carefully, right? These screws facilitate the motion of the instrument in horizontal. The lower clamp screw lock or release the lower plate. When the screw is unlocked, both the upper and lower plates move together. I already have explained. The associated lower tangent screw allows small motion of the plate in lock position. This tangent screw, when you see, say I am from 0 to one more point, I am trying to measure the horizontal angle. I have seen that object, I have tightened the clamp screws such that the instrument won't move, but my crosshair is not get coincide on that object. So I need to coincide exactly. For that, if you rotate this tangent screw slightly either forward or backward, then the scale will slightly move slowly. So if you hold on, then the minute measurement can be made. Similarly, the upper clamp screw locks or releases the upper vernier plate. When this clamp is released, the lower plate does not move, but the upper vernier plate moves with the instrument. This causes the change in the reading. The upper tangent screw allows the fine adjustment. So the upper clamp screw, lower clamp screw, both the things are attached by their own tangent screw also. The tangent screw makes for finer adjustments, right? So this has to be handled very carefully, right? Next is the plate level. Already I have shown. There will be a bubble tube. This bubble must be in center while completing our leveling portion, right? The single level or two levels fixed in perpendicular direction may be provided here and this way also. In some other instrument they will provide two, predominantly one, and another one here is the upper. Now we are going to concentrate this alone. The split level can be adjusted with the foot screws. Already I have shown the foot screws 1, 2, and one more thing will be the 3 foot screws based on their adjustment. The 7 is the leveling head, right? This, if you are adjusted properly, this bubble tube get managed to center. Next comes to the telescope portion. The essential part of the telescopes are eyepiece, the diaphragm with crosshair, objective lens and arrangement to focus the telescope. This eyepiece as a screw type model, this can be adjusted, and the objective lens can be adjusted by the screw in the side way, that to project or focus the object very clearly and the crosshairs clearly, right? Next comes to the vertical circle. Say this is the point. In the cross section it look like a straight line, but if you see in side way, it is a circle in the vertical direction, right, such that it carries C scale and D scale and the graduation of the angle. When you rotate the telescope upward or lower, it try to show the vertical angle, right? So the circular plate supported on horizontal axis of the instrument between the A frames. The vertical circle has graduation 0 to 90 degree in 4 quadrants. It also 360 degree only, but it will be represented in 4 quadrants: 0 to 90, 0 to 90, 0 to 90, right? The vertical circular clamp and the tangent. If there is a vernier scale or anything, when we need to measure, there will be clamp screw and tangent screw. You have to. With respect to horizontal, it is lower clamp, upper clamp. With respect to vertical also, clamping the vertical circle restrict the movement of the telescope in vertical plane. To hold on my position, this clamp screw helps, and to make the finer focus of the object and get the exact point, we have to use the tangent screw for that, right? So here this is the tangent screw for that clamp screw to make the adjustment in the vertical circle. Next comes the altitude level for the vertical. Highly sensitive bubble is used for leveling, particularly when taking the vertical angle. If you are only measuring the horizontal angle alone, the sensitivity we no need to consider. When you have to measure both the vertical and horizontal angle, both the bubble tube must be in center. And this is the axis and circles overall projection. You try to remember, there is a telescope, there is a vertical circle with for measuring the vertical angle, there is a horizontal circle to measure the horizontal angle, right? So this is the sight axis or the line of sight from eyepiece to the objective, and this line is perpendicular to the horizontal axis and also from the vertical axis also. So this alignment has to be made always perfectly by making the leveling properly with respect to the foot screws and everything, tripod. So this assembly you have to remember, right? So from this the major parts of the theodolite we have covered, right? I hope friends you have understood. Thank you.